Welcome to Control 4 Driver Development Essentials. My name is Peter Casenza. In our previous introductory video for the T-Series training modules, we introduced to you the concept of a Control 4 driver development template. That video offered a high-level review of what makes up a driver template and demonstrated the relationship between template components and actual device driver schema. In this video, and the remaining T101 training modules, we'll dive much deeper into each of the respective template areas. We'll do this within the driver editor environment and in an ordered manner that demonstrates good driver development practices. We'll continue to use the IP camera template and populate all of the template components which are applicable to creating an IP camera driver. If you haven't yet had the opportunity to do so, we recommend watching the T101 Module 1 training video. Reviewing that content will ensure that you get the most from this video. Let's start by opening up the IP camera driver template from within Driver Editor. Note that we're running Driver Editor in single driver mode for demonstration purposes. To open the template, click File, followed by New. This will display all of the currently available templates. Here is our camera template. Double-clicking it will load the template into the Driver Editor environment. The template opens by default to the Main tab. The Main tab is a good place to start populating the template. The first modification we'll make to the template is to update it with the appropriate camera information as well as some data that will be specific to our driver. Here is our Main tab, updated with new content. We've updated the default information with information that reflects the camera for which we're developing the driver. This includes new camera manufacturer and model data. We've left the default copyright and version information alone, as they are applicable right out of the template. The created and modified fields are useful as they can track when our camera driver was created, as well as any time that we make changes to it. Date and time information can be entered by using the incremental buttons on the side of each field, or you can click the clock icon to populate the field with the current date and time content. Additionally, the modified date value can be configured to auto-populate when our driver is saved or every time it is exported. That setting is found under the Options toolbar menu. Click on the Preferences, Export/Import, Dates menu. Next, we can assign a control method for our camera driver. The camera for which we are creating the driver is IP-based, so we'll select IP from the drop-down menu. The control field is used to designate if the driver uses the LuaGen or AVGen engines. If we were creating a simple one-way driver or a driver that relied largely on IR codes, AVGen would be the appropriate selection here. However, our IP camera is a two-way IP-based driver, so we'll select the LuaGen engine to handle the complexity that is inherent with IP camera control. You'll notice that the driver field is automatically populated with DriverWorks. That's because we've selected the LuaGen engine in the control field. If we had selected AVGen, this field would have been populated with C4 AVGen. The DriverWorks value in this case indicates that our camera driver will rely upon the APIs, proxy, and other camera supporting elements found in the DriverWorks SDK. The search field isn't applicable for our camera driver. It is useful for devices that support Control 4's Simple Device Discovery Protocol, or SDDP. If our device supported SDDP, we could enter the device's search string here. Since it does not, we'll simply leave this field blank. The Notes area of the Main tab provides us with a large section for entering information regarding this camera driver. We'll take advantage of this by including some information that may be useful to us when we review this driver in the future. Now that we've updated our template with the appropriate camera driver information, we can move on to the Proxies tab. The Proxies tab lists the primary proxy provided through the template. In our case, we can see that the camera proxy is listed. If this template supported multiple proxies, say for example a receiver tuner, those secondary proxies would be listed here as well. The Proxies tab makes it easy to modify the proxy provided in the template. Simply right-click anywhere in the Proxies window, and the Add, Edit, Remove proxy window is displayed. Let's say that we want to edit how the camera proxy is defined in our camera driver. Clicking on Edit will display the Proxy Edit window. The Type drop-down menu provides a list of all supported Control4 proxies. This would be useful if we want to add another proxy, but we only need the camera proxy, so we'll leave this field alone. You'll notice that a proxy binding ID is automatically assigned to the camera proxy by default. It is 5001. The name field is an optional value. It will let you override the default proxy name from the template and is useful if you want to name this proxy something different than the default value. This is helpful if you want the proxy name value to appear differently in Composer Pro. If so, you must populate the Use Name checkbox to the right of the name field. This will enable the name text box so that you can enter a more user-friendly name. For our purposes, the name of camera is fine. The checkbox to create virtual AV connection bindings from our new proxy to the primary proxy is grayed out, as that's not applicable to our camera driver. If this template were for an audio-video device, checking this box will build all of the necessary AV bindings between the primary proxy and secondary proxies for us. This topic will be covered more thoroughly in template modules where this functionality is required. Clicking OK will save the camera proxy information for us. Now that we've made our proxy configuration, we can move on to Capabilities. The Capabilities tab provides us with an opportunity to see the camera template's default capability list. The Capabilities area of Driver Editor functions very similarly to the proxy screen in that we can add, remove, or edit driver capabilities by right-clicking. Based on the camera for which we are creating this driver, we need to modify one of the capabilities. The Proxy and Protocol Guide indicates that the Number Presets camera capability defaults to a value of 0. Our camera actually supports 4 presets, one for each polar direction setting: north, south, east, and west. While the actual naming and UI display of each of these preset settings is handled elsewhere in the driver, the number of presets needs to be defined correctly in this capability. We can modify the Number Presets capability value by right-clicking on the capability name and selecting the Edit Capability option. Here we can see its default value of 0. We'll change this to a value of 4 and save the updated capability. This completes all of the capability modifications that we need for our example camera driver. However, your role as a driver developer will be to examine each of these capabilities and modify any that require configuration to support your camera's functionality. Up to this point, we've used the Driver Editor environment to modify the main, proxy, and capabilities content of the supplied camera driver template. In our next video, we provide examples on how to populate the necessary elements found on the Configuration and Connections tabs.